In this segment, we will view the DFG-100 wiring schematic and see the components of the unit in action, while the different features of the unit are operated. The following electrical signals are present: ground, 115 volts AC, AC neutral, 24 volts AC, 24 volts AC neutral, high voltage spark, flame rectifying microamp current, and the resistance of the potentiometer and probe. We will start by looking at the diagram with the unit off and the cord being plugged in. When power is applied to the unit in the off mode, it will be present here. Now we will put the unit into cool down and put the fan into high speed. Here we see the mode switch pass voltage to the fan speed switch, which feeds the motor high winding. This causes the motor to rotate in a clockwise direction at 5.4 amps and 1,725 RPMs. While still in cool down, we will switch the blower to low speed. The voltage switches to the low winding of the motor. Low fan runs at 2.6 amps and 1,140 revolutions per minute. Next, we will hold the momentary light switch in the on position to turn on the lights. This feeds voltage to the lights. They're located in the rear of the unit. While in cool down, if the control panel is still warm, the cooling fan thermostat will close at 110 degrees and feed voltage to the axial cooling fan. The cool air pushes the warm air out of the rear of the unit. Once the panel is below 90 degrees, the thermostat will open and the fan will stop. While in cook mode, the axial fan is on all the time, but in cool down or off mode, the cooling fan thermostat controls the axial fan. Here we see the cooling fan thermal switch close, while the unit is in cool down mode, to feed voltage to the axial fan. The axial fan rotation is shown here. Next, we will turn the mode switch to cook, open the door, and make sure the thermostat is not calling for heat. We'll also leave the timer off to see what voltage is present. When the door is open, the switch plunger is out. When the door is closed, the switch plunger is in. Here we can see in cook mode that the axial fan, temperature control board, the transformer, the centrifugal switch, the door switch, and the timer are all reached with 115 volts AC. We will activate them one at a time to review each one. To operate the timer, it's recommended to turn it up past 30 minutes and then back to the desired time. We will also watch as the timer goes off to feed the buzzer. When we set the timer, we feed the timer motor. When it times out, it sends voltage out to the buzzer. Next, while still in cook mode, with no call for heat, we will close the door. The door switch sends voltage to CR1, and the relay then sends voltage to the motor through the high-low switch. When the motor rotates, the centrifugal switch closes. Here we see the switch close when the clutch in the motor drops. The centrifugal switch then feeds the thermostat relay and the blind terminal 6 of the ignition module. Note that the door switch also triggers CR1 to close these relay points, which are not yet used. Blind terminal 6 has no circuit traces on the ignition board. It is never referenced by the module. Next, in cook, we will trigger a call for heat with the door open. The temperature control board, the potentiometer, and the probe control the call for heat. When turning the potentiometer up, hooked to yellow and violet, the reading will go from high to low. When turning the potentiometer up and hooked to yellow and orange, the reading will go from low to high. As the potentiometer is turned, the ohm should smoothly increase with no shorts or open segments. Now let's take a closer look at the probe. Here we see it inside the oven cavity. At 75 degrees, the probe reads 105,000 ohms, and at 300 degrees, it will read 1,890 ohms. This is the temperature resistance chart for the DFG-100 solid-state infinite probe. Notice, if the probe reads open or shorted, it has failed and needs to be replaced. Now we see the board's supply voltage, the T6 common to the heat relay from the centrifugal switch, the potentiometer, and the probe. When the temperature set point is above the temperature of the probe, the heat relay closes, sending voltage out from T7. Here we see the potentiometer, probe, and temp control call for heat by closing the heat relay. Because the door is open, no voltage was present at T6, so T7 cannot feed out a signal. Here at the board we see T6 missing, which also prevents T7 output from the relay. The potentiometer, probe, temperature control board, door switch, fan centrifugal switch, heat cutoff switch, CR1 relay, and the transformer make up the first half of the heating circuit. Next, we will close the door while the oven is calling for heat, but the gas shutoff switch will be off. When the door is closed, CR1 receives coil voltage, allowing it to pass voltage to the motor. When the motor is running, the centrifugal switch closes and voltage is sent to and out of the heat relay because a call for heat is present. The voltage is stopped at the open gas shutoff switch. Next, we will turn on or close the gas cutoff switch. This sends voltage to the ignition module. Once voltage is received at the module's terminal 2 THS, the focus shifts to the ignition module, the gas valve, and the pilot assembly. When 24 volts AC arrives at terminal 2 of the module has a 4-second pre-purge. It then sends voltage to the pilot valve and spark to the pilot. This ignites a pilot flame that sends microamp rectification to the module on the flame sensor wire to terminal 4. When the module sees the minimum rectification current at terminal 4, it sends voltage to the main gas solenoid and the oven ready light. Here we see the sequence with the actual components pulled from the unit for clarity. The module, the gas valve, the gas lines, the gas supply, the burners, and the pilot make up the second half of the heat circuit. Here we see the heating pattern of the DFG-100. The burner heat wraps around the oven cavity, radiating heat into it. Then the heat is pulled into the oven cavity at the heat collector behind the blower wheel. The heat fills the oven and is exhausted out of the 3 holes in the front of the top of the oven cavity. It flows then out of the flue of the oven. When the main gas solenoid is fed, the oven ready light is also energized. When the unit reaches set point, the call for heat ends. Here we see the call for heat ending on the diagram when the probe shows that the set point has been reached. If the oven requires calibration, the potentiometer shown here can be used. Refer to the service manual for the calibration procedure.